Now the comparison between R is equal to A plus TB. This is one straight line. What is the characterization of this straight line? It passes through the point A parallel to vector B. Such a straight line and a plane. How is this plane? R minus C dot D is equal to 0. This plane passes through C perpendicular to D. You remember this characterization. This D is perpendicular to this plane. This B is parallel to this line. That points you remember now. Now the comparison between them, one line and one plane, let us compare now. So here the line passes through the point A, whose position vector is vector A and parallel to vector B. So it is like this. This is origin here. This is the point A, whose position vector is vector A and parallel to vector B. Vector B is like this. That is exactly this line. You observe this line throughout the line. This line passes through the point A and parallel to vector B. This is exactly the line we are discussing about this line. Now let us try to imagine what is this plane. This plane passes through C perpendicular to D. Let us draw that is plane passes through C perpendicular to D. This is the plane, right? It passes through C perpendicular to D. So this D is drawn. D is a normal to that plane. You observe here, D is a perpendicular to the plane. B is parallel to the line. That point you remember it. You visualize that. B is parallel to the line. D is perpendicular to the plane. That points you remember. Now, very first thing, what is this point of intersection? Here, this line is there. From below the plane, it is intersecting the plane. At this point, it came out, that line is going like this. Then this is exactly the point of intersection. What is this point of intersection? I want to calculate from here. So let me calculate this point of intersection. Let me assume that this point of intersection is P naught. What is this point to P naught? Point to P naught means what is the position vector of the point to P naught? I want it, right? But position vector of a point to P naught will be definitely one of the point on this line for some suitable t, right? So this point P naught, whose position vector I am assuming vector R naught. So I want to write what is the position vector, that is R naught, right? Now this is R naught. That is R naught is same as A plus TB for some suitable t. As you give the different values of t, we will get the different points on this line. For some suitable value of t, this point also lies on this plane. Means in place of this R, A plus TB should satisfy that. That is, in place of R, A plus TB is substituted. Then A plus TB minus C dot D should be equal to the 0. From here, distributive property A dot D plus T times B dot D minus C dot D is equal to 0. From that T value will be C minus A dot D by B dot D. That implies that for this T value, A plus TB also lies on this plane. Means when you substitute this T value, whatever this R naught position vector you are getting, that is A plus, in place of T substituted this T value, then it is a point on this line as well as it is a point on this plane. Means this is exactly the point of intersection of this line and this plane. That is exactly P naught position vector. So this is exactly the position vector of its point of intersection. So first part is clear. Now let us see the second part. Angle between the line and the plane. Here you observe here, this is the line. And here this is the plane. Angle between them means you draw the projection of this line on this plane. Now, this angle is exactly the angle we are talking. This angle is called angle between that line and plane. If this angle is theta, I want the value of theta. But you observe here, because D is perpendicular, once this angle is theta, then we know that this angle is 90 minus theta. This is 90 minus theta. Now, to evaluate theta, let me calculate 90 minus theta. From that, the theta will come. Now, on this 90 minus theta, 90 minus theta is the angle between vector D and this straight line. But this straight line is parallel to B. Means 90 minus theta is angle between D and B. Therefore, cos of 90 minus theta is angle between B and D, that is B dot D by mod B mod D. But from here, this cos 90 minus theta is same as the sin theta. Sin theta is B dot D by mod B mod D. Therefore, theta is sin inverse of B dot D by mod B mod D. So this is exactly the angle between this line and this plane. Right? Now let us see the next one. This line totally lies on this plane. This line totally lies on this plane means this angle theta is 0. This angle theta is 0 and P naught lies on that plane. Its meaning is that. So its meaning is that, you look here, that is every point on this line should lie on this plane. Means when you substitute R is equal to A plus TB in place of R, then this condition must be fulfilled for each real value of T. That is same as A plus TB minus C dot D must be equal to the 0 for each T. For each T it is 0 means I can write this as A minus C times D plus T times B dot D. That is implies that A minus C dot D should be 0 as well as B dot D should be 0. If this both conditions are satisfied, then this line totally lies on this plane. Or else you can imagine with common sense. With common sense is that B dot D is equal to 0. Means B and D are perpendicular. Means this D and B are perpendicular. Means this B is parallel to the plane. Right. That implies that a line is parallel to the plane. So line is parallel to the plane. And this condition says that A minus C dot D means that C lies on this plane. That is A. A lies on this plane. Means one of the point on this line, A lies on this plane. Means one plane is there, one line is there, such that that line is parallel to the plane. And one of the point of the line lies on the plane is possible only if that line totally lies on the plane. That is exactly theoretically we proved here, and with common sense also we can understand. Now the next one is that line is parallel to the plane. Line is parallel to the plane means is that only just parallel. I am not expecting that that line totally should lie on the plane. Once a line is parallel to the plane, means this B must be perpendicular to D. That is B dot D should be equal to the 0, right? And the line is perpendicular to the plane. That line is like this. That line is like this means B is parallel to D. B is parallel to D means B cross D should be equal to the 0. This is the condition for which that line is perpendicular to the plane. So these things you can observe with common sense. Whenever while solving the problems, all these things are required in the mains level and advanced level. That is the reason I have discussed here.